And again, we continue with multiplication. And again, I'm going to say it. You're only multiplying one digit by one digit at a time. There's zero reason to think multiplication is difficult. Use your tools. In a few minutes, you'll be getting multiplication steps to glue into your journal. Don't glue them in, shut your journal, and never look at them again. They're there to help. Otherwise, I wouldn't waste my glue. Otherwise, I'd use it on you guys as chapstick. Oh, no, he didn't.
I don't have chapstick.
All right, so I know, I would use mine. Let's go 56 times 39. We're going to start with that. Our factors are 56 and 39. Factors are the numbers that are multiplied together to get our product. And I know you all are watching. I know you all are watching because you love good grades and you cannot lie. First, I estimate, I'm going to make that 60 times 40. Now, I realize I estimated up, so my answer is going to be less than what I get here for 60 times 40, because I made both of these bigger. All I need to know is 6 times 4, which is what? 24. Then I have 2 trailing zeros. To find my estimate, I just needed to know what 6 times 4 was. Then I put the 2 trailing zeros on there. So my estimate is 2,400. My actual answer is going to be less than 2,400 because I rounded these both up. Now I could round them both down and find it'd be lower and our answer would be somewhere in between. Now let's look at just the standard algorithm first. I have 56 times 39. I'm only multiplying 9 times 5 and 9 times 6. Y'all all can multiply 9 times 5 and 9 times 6. What we're doing in this step is we're multiplying 56 times 9. That's all this step is 56 times 9. So if I go and I don't know, I can look at my multiplication chart. 9 times 6 is 54. That's 54 ones, or 4 ones and 5 tens. 9 times 5 is
45.
plus the 5 50. So I have 50 tens or 5 hundreds. I don't want to carry around that. 50 tens in my wallet would be, well, it'd be unprecedented because I don't make that much. Okay, so 56 times 9 is 504 as long as we did our math correct. Now what we're doing here is 56 times 30. Why 30? Why 30? Anyone?
Because you already used the 9, so it makes the 3 30 because it's in the 10s.
Good. My 3 is in the tens place. That's where that 30 came in. That's where that 30 came in. So since I'm in my tens place, then I do 3 times 6, which is, so I have 18 tens, or 8 tens, and 100. 3 times 5 is?
15.
Plus 1 more is?
16.
So 4, 8, 11, 2,184. Okay? I knew it was going to be less than 2,400. But wait, there's another way that many children like to do it. I could do 50 and 6.
I think the phone's ringing.
I think it's ringing too. So
I
just
said
think
first,
about that. I could do 50 and 6.
I think it's running too. You like
Oh, all right, I can do 50 and 6. This wasn't freedom to speak. I could do 50 and 6. And then I would do 30 and 9. Again, all I have to know is 9 times 6, 9 times 5. 3 times 6, 3 times 5. Y'all can do that. What is 9 times 6?
54.
54. What's 9 times 5?
45.
45, plus I have this extra 0 here, that trailing 0, that makes it 450. What's 3 times 6? 18, plus I have a trailing 0 here, which make it 180. What's 3 times 5? 15, plus I have 2 trailing zeros there, which is going to make it 1,500. Then I just add these 4 numbers together. And as long as we did all our math correctly, it's going to equal 2,184. This is the way a lot of kids like to do it. I don't care. This is the way all old people were taught. Just a standard algorithm. Just do it this way. This is how we were taught.
I don't know. Wait.
Let's look at one more.
Dad actually, when he has to help you with my math.
Shh. Let's look at one more. Let's make this a 3-digit by a 2-digit.
Okay.
So let's make it
139.
297 times 84. 297 times 84. So we have a 3-digit factor and a 2-digit factor. Remember, the factors are the numbers being multiplied. So 297, we're going to say is 300. Times 84, we're going to make 80. All I need to know what 3 times 8 is, which is 24. I have 3 trailing zeros. So these 3 zeros are going to go here. Now, those of you that are going to do this and not do it correctly, it's not because you don't know how to do it, but some of you are staring off into space. My answer should be somewhere around 24,000. Standard algorithm. 297 times 84. My first line is going to be 297 times 4. My second line is going to be 297 times 80. So that's a third way you could do it. If you want to do it that way. We have the lattice method, not lettuce. Lattice method we could do. What's 4 times 7? 4 times 7! 28. I'm going to ask you every one of them now. Ian, 4 times 9?
4 times 36.
36, plus the extra 2 we regrouped.
38.
38. So 38 tens or 300s and 8 tens. 4 times 2, Ian?
8.
Plus the extra 300s is?
11.
So 297 times 4 is 1,188, as long as I did my math right and my good man Ian did it right.
I think I did.
Now we're starting in the tens place. We're starting in the tens place. So Ian, 8 times 7. 56. So that's 6 tens and 5 hundreds. Ian, 8 times 9. Your neck's going to get sore if you don't memorize these. 72. See, I would do 8 times 10 because I know that's 80. And then I would just subtract 8 of them because I only want 8 times 9. So 72, plus we have this extra 5 up here, so that would make it 72 plus 5? 77. Ian, 8 times 2.
16.
Plus the extra 7 we have. 23? I don't know. Speak up now or forever hold your peace. All right, so then we would just add these together. 8, 14, 9, 24,948.
Yay, I actually
Okay.
got something.
Fairly close. Fairly close. The other way we can also do it is 297 we can do 80 and 4. 80 and 4. And then we're still doing one digit by one digit. What's 4 times 7? 28. What's 8 times 7? 56. Plus we have this 0, so this is going to be 560. What's 4 times 9? 36. Plus I have that trailing 0, so it should be 360. What's 8 times 9?
72.
72. Plus I have 2 trailing zeros, so that's going to be 7,200. What's 4 times 2? 8. And I have these 2 trailing zeros, that's going to make it 800. What's 8 times 2?
16.
16. I have 3 trailing zeros, so that's going to be 1,600. And if I added all 6 of these together, and I do it all correctly, and I've done my math correctly on the other one, we should get the same product. Now you could have broken it up, like I said here. You could do 297 times 4, 297 times 80, and then added those 2 products together. So, I mean, you know more than one way to skin a cat. I don't know. It's an old saying. I don't know why you'd want to skin a cat, but it's an old saying.
I don't have a